Good afternoon, everyone. Welcome back to the ECTI Conference 2025 hosted byฬาลงกรณ University. And this is a special session, Human Resource Development for Semiconductor Industry via the Bachelor degree program in Electrical Engineering and Semiconductor Engineering. This afternoon, I'm very delighted to have with us the three panelists from the leading company and organization that will play a critical role, instrumental role in driving the semiconductor industry, research, development, and the business for Thailand. Let me first introduce the first panelist, Mr. การโอภาสจำรัดกิจ from the Silicon Craft Technology. Please welcome คุณการครับ And next is Dr. อนิวัฒน์ตันเดชานุรัตน์ from the PTT Public Company Limited. And now Dr. อนิวัฒน์ serves as the General Manager of the FT1 company, the joint venture between the PTT and the HANA, for the set of the first foundry of fabrication industry, fabrication factory in Thailand. And last but not least, we are glad to have with us Dr. พุทธพล เพ็งพัฒน์ from the Thai Microelectronics Center, or as we know, TMEC. So welcome our three panelists, and thank you again for being with us this afternoon. And my name is แนบบุญหุนเจริญ from Department of Electrical Engineering at จุฬาลงกรณ์ University, and also serve as the chair of the new Semiconductor Engineering program, as you can see in the background. This is the new program as an international program under the collaboration of the ISE together with the Electrical Engineering Department จุฬาลงกรณ์ University, and we will start welcome the first batch of students to this program starting from this academic year. So as indicated by the topic, today we are going to discuss and talk about the plan to develop our young talents to grasp the opportunity of the semiconductor industry, semiconductor related industry in Thailand. And I would like to also invite all the participants to be active participants. So after you listening to all the panelists, please feel free to ask any question that you may have after we hear the information from our panelists. So first of all, let's start with maybe for some of the participants that who are quite new with the semiconductor industry. May I ask from each panelist, what do you see as the unique characteristic of the global supply chain in the semiconductor industry? And as we may hear about the chip war, the bestseller book, what is this war about, and is it going to affect Thai people, Thai economy with this chip war, so to speak? So and perhaps you could also introduce your organization, your company, your role, and where is it in this global supply chain of the semiconductor industry? Let's start with คุณการ from the Silicon Craft ครับ
Thank you, Dr. Nebun for introducing, and very interesting topic to talk about. So, okay. Good afternoon, everybody. So, let's talk about the global supply chain of the semiconductor first. Okay, so we're not talking too detail about Silicon Craft because it is already listed in the set in Stock Exchange of Thailand. You can find more information about Silicon Craft a lot every quarter. So I'm here today. So together we would like to share your insights about the semiconductor industry. So the reason why it is so important that it create a war, let's say why America and why US and China trying to be the first or the biggest player in this industry, because it's really the backbone of the future technology. Even you are looking for the AI, the clean renewable energy, every smart devices is already powered by the chip, the silicon, the semiconductor, that is the hardware of everything nowadays. And it also promised the future of new devices like for space and even your neurotransmitter that your brain can talk directly with the computer through the semiconductor chip. So that's why it's very important and it's a very exciting topic to be the owner of the technology, also the owner of the business that based on the semiconductor. So it's growing at a very quick growth rate, like 7% for 10 years, and on average, which is very good for some technology that is already 70 years old. And you can see the impact of the technology. All semiconductor technology is charted by a roadmap or one rule that called the Moore's law. So Moore's law say that every 2 years the computing power will double and number of transistors in the same area will double. So that doesn't see the impact much. But if you saw the application that it's creating from just the PC, the bigger PC, then it's smaller, become the laptop, become the smartphone, and now it's a talking computer that be your companion. So the future will be very interesting. So that the opportunity for the semiconductor. And then what is the challenge? So because it's so important, everyone trying to snatch it for themselves. So the first thing is the political risk, and coupled together with the supply chain, and together with the COVID. Now our big guys, the America, the US, just realized that everything, 90% of everything is made in China, and that's very concerned about their security. Then now they create some chip wars, or what you may call. Sorry? 90% made in Taiwan. Yes, that in Taiwan and. Okay. Thank you. So that's the okay, but it's because it's very close to China, and that's something to concern. Even more, I think it's in the rest. Maybe 50% or 70% of the rest also made in South Korea, Samsung. So that very concerning. So that's why the first thing. Now everybody, even Europe and US, trying to have their own supply chain in their region. So you see the tariff war, the hard and soft measure to draw everything back into their region or their country. The second one is the more severe thing, but it's not so obvious, is the talent shortage. So we are not, usually the semiconductor people come from electronic engineers or chemical or material engineers, but that's not the very famous topic for more than a decade now. So everybody so exciting about computer engineering, data science, even AI. But now they know that it's very the backstage guy that is so important, but we are forgetting about them for so long. So now we come back to the same problem. We cannot produce them enough for the future. And the third one, even though they are more risk, but I would like to point out the topmost three. So the last one is the complexity of the technology. Becoming smaller is not come free of charge. The more investment has to put it into producing 2 nanometers or even 1.4 nanometers. Even going lower, the cost of design and producing is going maybe 2 times or 3 times higher than the cost they save making a smaller chip. So that's the 3 things that is most pressing semiconductor industry right now. And for the situation of the supply chain, I think Thailand can say that Thailand is in the strong in the downstream. We have the packaging and testing and the assembly, the electronic product. So right now I think it takes too long to say about everything. So I will keep it. So Silicon Club we are a bit different from major player in Thailand. We are the fabless company. We designing the chip and outsource the rest of the process to some fab in abroad and then bring it back to Thailand to package and testing. So we have some exciting future ahead with the coming of some big company that want to create the IC design division like analog devices and Nishinbo in the north. Also the FT1 and we have EIC semi for discrete power device in Thailand. But we still have a big gap in order to be complete the ecosystem of the semiconductor in Thailand. So what is the risk for when we scope down to Thailand? I think because of the long time we neglecting about this industry. So we have like severe shortage of people. We lack of the ecosystem that's supporting the front end. I mean the wafer fab, we don't have the good material in the country. We have waste management is also the problem with the ecology. And sorry, I'm not sick, may I stand a little? So we come late because like Vietnam and Malaysia, they prepare for many years before they get the good deal, the good investment. And also the money is also the key important because semiconductor is the capital intensive industry. So we need more money and actually our country is the less paying. I mean the government spend, if you compare every country in Asia, I think we can say that Thailand has the less exciting, let's say, exciting support campaign for big guy like Intel or other like Nvidia to invest in Thailand. So that's another challenge. And finally, so we think the opportunity for us is in the strong of the OSAT. If we can expand from their capability from right now and make them able to do the more than more packaging, do the final product that is very advanced device like smartphone and smartwatch, that would be utilize what capability we have right now and upskill, reskill current workers in this industry. And maybe the last point I would like to talk about is the capability to design the electronic and analog like sensor, radio frequency and power system. That would be something that not many people even in the world can do it well. So that could be our strong point that can utilize. So I'll stop here. Thank you.
Thank you, Kun Kan. May I have the quick question before we move on to Dr. Yun? When you said more than more, and once I visit TSMC, I heard this phrase as well. You said some of you know about Moore's law, right? And when the leading company said beyond more or more than more, what does exactly mean to that phrase?
Okay, so because Moore is talking about reducing the size of transistor, but as they face the wall, right now they have to think another way. So they go like going up and combining with things that can work better than silicon alone. So more than more is like you combining in the vertical like 3D, like using different devices to make the better than silicon to transmit electron, and also maybe connected with photonic to send the signal out faster than using copper wire, stuff like that.
Thank you. And another quick question. Nowadays, everyone, every corner, every sector talk about AI, and AI. How would you relate semiconductor technology with the AI development?
Okay, everyone know NVIDIA. NVIDIA is a chip company and the fabless one. No factory, they design the chip. And NVIDIA, everyone relate NVIDIA is equal to AI. So why? Because NVIDIA design the chip that can do the parallel processing very quick. So they start from the GPU, like 10,000 core in the single chip for graphic processing. Right now, that capability they turn into some convolution metric thing that very complex, and they make it for deep neural network, which is the algorithm that can turn into the hardware. And by making that hardware in parallel a lot and making the chip the most fundamental component, which is the transistor, very small and small, they can put more and more processing power into the single chip. So that's why the AI can do many things that we unexpected today.
So may I say that the success of the AI depends heavily on the semiconductor technology
Exactly.
behind that. Okay, thank you very much. Now we move on to Dr. Aniwat or Dr. Yun. From your experience, okay, in this industry, can you share your insight on the global supply chain of the semiconductor industry, and also what present the challenge and present the opportunity to Thailand as a country?
Okay, thank you for the introduction. And it's my great pleasure to be here and to join this panel discussion session of the ECTI-Icon 2025. My name is Aniwat Tandechanurat. I'm leading the Semiconductor Business Unit of PTT Public Company Limited of Thailand. We are the fully integrated energy conglomerate company working on the full value chain in oil and gas. So you might think that you might wonder why we are having an interest in semiconductor world, because while Silicon Craft is trying to fill one gap in the upstream capability relating to chip design, PTT and FT1, which I will explain later, we are trying to fill the other gap in upstream capability, which means the wafer fabrication technology in Thailand. Okay, so in another role, I'm a general manager of the FT1 Corporation Limited. Our mission at FT1 is to build the first commercial scale wafer fabrication plant in Thailand. And we think that this FT1 is a subsidiary of PTT. So if we think from the perspective of PTT, we are a state-owned enterprise. In order to achieve our mission of the responsibility for society, we think that we need to help upshift Thailand industry into the new or more advanced technologies. So in this session, I'm going to draw you a picture from our idea of building the wafer fab to improve the capability of Thai industry into the execution and reality. Okay, so let me start from the overview of the industry, especially in this region, okay, of ASEAN. So electronics and semiconductor industry is the third largest industry of Thailand. It accounts for like 14% of the GDP of the country. Okay, but if you look, okay, at the plot on the left, we have barely grown. Okay, our electronic sector has barely grown compared to our competitors, especially Singapore, Vietnam, or Malaysia. Okay, so Malaysia is trying to move themselves to more upstream side. They are focusing on chip design. They are focusing on building their own brand of the chips and so on. While Vietnam, they are focusing on investment in talent. Okay, India is another important example. They are trying to move themselves to the vertically integrated player in many advanced industries like automotives or EVs or the AI. So meanwhile, if you look at Thailand, our I would say national champion products in these past like 10 or 20 years are still relying on hard disk drive and electrical appliances, okay, which lose global relevance in these past few years, okay, especially due to many reasons, okay. The main one would be like because we lack R&D activities, we have underinvestment in advanced technologies, we lack skilled laborers, and also we don't have a clear national strategy in semiconductor and related supportive policies. These are the problems that we need to solve in order to move Thailand forward. Okay, these pictures shows a very clear example of how Thailand is lagging behind compared to other countries. Okay, if you look, okay, the first quadrant on the top right, this is where every country wants to produce products that the world wants. Okay, they are the new world products with highly advanced technologies. But you can see that Thailand has nothing in this quadrant because every product that Thailand can export well into the world are outside of this quadrant. We are doing very good in ICE cars, hard disk drive, electronics IC, solar PV, and so on. We need to do something, okay, to try to move these industries in the country to the top right quadrant. One potential way is to adopt or exploit semiconductor to upshift the advancement of the technology. Okay, as you can see in the blue bubbles, okay, these are the industries that have potential to make use of semiconductor to improve their competitiveness in the global context. Okay, let's talk about the economic rationale before we go to the more technical thing. Okay, every dollar invested in new industry like semiconductor can create more GDP than the investments in traditional or established industries. Okay, why? Because investments in new industry like semiconductor usually brings in a new supply chain, usually brings in a new ecosystem into the country. So we will have a peripheral suppliers or supply chain that can also be shifted to the more advanced ones. Okay, so if you look on the right, semiconductor industry already has a very deep root in Thai economy, accounting for about 25%. So it means that if we can uplift this industry, there will be like a quarter of the total industry of the country that can also be upshifted with one investment in one industry. Okay, unlike other industries like aviation or medtech. So this is the position of Thailand in the semiconductor and smart electronics value chain in the present time that Khun Khan has touched a bit. So we are doing very well in midstream and downstream, okay, where we are packaging the chips. We are integrating those chips into electronic board or even the final product assembly. We are doing very well, and we have a very large manufacturing footprints already in Thailand. But what we lack is in the upstream side, okay, which means the chip design and wafer fabrication. For chip design, we have only a few companies, local companies, that can do the design of the chip. Silicon Craft is leading in that role. But I would say that none of them has a scale that can be competitive in the global industry. So this is one thing, one very important point that we need to improve. Okay, but there is also another point that Thailand needs. It is the wafer fabrication. Okay, which is the point in the value chain that we receive the design from the chip designer and fabricate into a physical chip onto a wafer, okay, which needs a lot of high-tech processes in order to make such a complicated patterns. I will go into more detail later on. Okay, so having an upstream capability in Thailand is not all about having a new plant of wafer fab in Thailand. It's not only that, but having the upstream capability would also create more GDP, of course, and it would strengthen the negotiating power in geopolitics, which is very critical currently, and also the technology security. And also, if we have the wafer fabrication in Thailand, it will help insulate Thailand from the global shortage, okay, when it's happening. And also, when we have the wafer fabrication or upstream capability, we can use that as a home ground for building talents and building up the R&D capabilities in the country too. And most importantly, when we have a new investment in new technology, we can use that as a starting point to build up a new ecosystem in the country. Okay, I think I will stop here for now, okay, before going to more detail later on.
Thank you very much, Dr. Aniwat. If you may share how PTT see the opportunity of this semiconductor industry, because in the past PTT is the leading in oil and gas company, right? So at present, looking forward into the future, how PTT as a company, as a public limited company limited, see this opportunity, if you can share with us, and any progress on the construction of the very first factory.
Okay, because PTT is an energy company. Okay, so currently we need to think about the net zero emission and also the energy efficiency, how we can maximize the efficiency of the energy utilization. So it is not only the production of the oil and gas or petrochemical products anymore, but we need to facilitate how we can use the energy more efficiently. This is why we think that because the main devices that are using power is electronics and electrical devices. So if we can invest or do something that can improve the energy efficiency, that would be a plus to our core business of power. This is why we think about the semiconductor, and to be more specific, we are going to focus on the power chips that can improve the efficiency of energy utilization in any electronics devices. Okay, so if we do well in that context, that will help also our core business like the hydrocarbon and the energy industries. For the progress of FT1, we are still designing the plant, and the soonest that we can start the mass production would fall in 2028.
Thank you. And another quick question: how would you relate the semiconductor with the EV? because I also heard in the news that PTT also have an eye on the EV business. Is semiconductor and EV are related somehow?
Yes, of course. Because in one EV, if you look at the cost structure, about 20% of the cost for the total cost of the car, of the EV, relies on electronics. Okay? And in that 20% of the cost, about 5% is coming from power. It's coming from power chips. So we think that if we can create the new ecosystem for semiconductor, especially the power chips, that will help improve or help build the local supply chain, okay, for EV in the country. We don't want to rely on foreign countries completely as we are doing now.
Okay. Thank you. Now it's time for our next panelist, Dr. Putipon from the TMEC, Thai Microelectronics Center, right? And I heard this, the name of this institution for quite a long time. You are, if not very first R&D who has done and established the fabrication, research and development in Thailand. As TMEC, how would you see this current situation, chip war, challenge, opportunity, and how would that affect the direction of TMEC, if you could share, please?
And thank you, Dr. Nepun, for introduction. And good afternoon, everyone. My name is Puttapon Pengpat. I come from Thai Microelectronics Center. We, as a part of NASDA, the National Science and Technology Development Agency of Thailand. So we are a government agency. And as everyone know that Thailand nearly got the front-end fabrication around about 20 years ago. We got the plan from the private company that they try to start like a Silicon Valley in Thailand. The company called Semiconductor on that day, but the situation is bad because our currency changed in overnight from 25.
Tom Yam Kung you are talking about.
That situation. So the company cannot establish, and the company just want us to help to develop for this kind of technology. So they lend the land of their land in Chao Chung Sao to build our facility there, and that we continue to start our fabrication bit by bit. We continue to correct the machine and complete the silicon CMOS technology around 15 years ago. And after that, the fund is quite hard to have from the government. So everyone forgot about how important of the semiconductor industry of that time. So me is one of the government scholarship students. They sent to learn how to make the chip. We come back with a few students, around maybe 7 to 10 of us still there in the TMEC. So we try to continue to keep our knowledge with not much money that we can get. So we can follow the trend of the technology as much as we can. And now we still keep the line of the machine, the CMOS machine, still working until today. The age of the machine is a bit quite old. We got one older machine, it's around about 40 years old, but it's still working, functioning. So today I will share you what we done in the TMEC, and recently, about past 3 years, we have the study that if we want to have a new fabrication foundry in Thailand, what would it be and how it compete in the market today. So our study we will share with you today in the slide. So let me start. We dive into the semiconductor industry. So firstly, I will introduce you to the cycle of the electronic device fabrication. We start with the circuit design, layout design, like the silicon craft TUI, and we divide into the front end and up and back end process. The front end finish with the vapor fabrication and testing, and the back end will start from packaging and to the electronic products. But in the view of marketing, you should do this first to design the product by and creativity in your products, and then what your product want to function, you design it and talk to the the circuit design chip to do the thing that you want. So it's a backward in the view of the marketing. So like the model that we talked earlier. So I will just say that everything in this technology made it smaller and smaller every day, every year. What the benefit of the smaller chips? So it will, of course, smaller chip increase the density per chip. You got a faster and lighter working chip and low power consumption. And this one is the technology that used in the chip start from the earlier state that is done on planar MOSFET, and the design evolved to 3D dimension that can scale down chip from the node of 10 to 22 nanometer into the less than 3 nanometer today. And the fabrication process is like, I can say, it's like a kind of stacking, making the structure like a stacking up. So you can see this. It starts from the silicon wafer and the process of deposition, thin film. It will be the metal film or isolator film. And then it will come to the process of patterning and etching and implantation to make the semiconductor material to be a conductive material on the selective area that we want. This is one of the cross section of the multi-stack of the one chip. So you can see the topology on the MOS here is limited by the lithography technique, and the hole that we do on the thin film is limited by the lithography technique as well. And the chip will complete the circuitry by the metal film that fill in the hole and get the electrically connection and finish the chip hole, the whole chip. So this one of the machine that the most expensive in the line of the production, we call the lithography machine. The one that can make the very tiny topology and tiny hole to do the fabrication. And today they will down to maybe less than 2 nanometer. And the machine is very expensive. In TMIC, we just got only 500 nanometer machine on this scale. Cannot be compete with the world, I have to say. But how can we follow up the technology? I will tell you later. So this one show the semiconductor industry ecosystem. The information come from our study on 3 years. We start to study from 2022, maybe 3 years ago, right? And the forecast to the 2030. You can see the material section of the industrial ecosystem is not just a silicon. They got germanium, gallium arsenide, silicon carbide. Therefore, Kunkan like to make a power device in the FT1, maybe use the silicon carbide and silicon nitride as well. For the gallium arsenide, it will be built on to the photonic device. So the silicon ecosystem is not just the IC. It's a lot of many things there that I will introduce you later. But I will have you focus on this pyramid, right? The ecosystem is start from electronic design automation, EDA tool, the tool that Silicap should be very familiar with, because they need to use to design and then send the design back to the top of the pyramid in the chip foundry, right? TSMC or Samsung or any other foundry that make a chip for every brand, not just the own brand like this one. Intel make the chip just only their brand. And you can see the connection between the design and the fabless chip company. If you see the fabless chip company, two of these companies is very big name and very rich in the top of the list of the company of the richest in the world. So it's quite an opportunity for us if you produce a student that can design the IC and maybe can make the startup company to do something like this, because you can springboard from on the bottom of the pyramid to nearly the top of the pyramid, as you can see in this ecosystem. Okay, like I say, the silicon ecosystem is not just IC. You can see that more device is a nickname of IC device, but more than more, TMT is the device that we already use every day as well. It's a kind of sensing device, actuator. For example, in your mobile phone, you got the image sensing for your camera, right? The microphone, the speaker, the touching screen, and every accelerometer inside your phone, you can flip it, you can look, you can, and some of advanced phone, you can got a 3D scan of your face. So you can do a facial recognition. That is the more device, I have to say. And it includes the communication chip, like a wireless chip, Bluetooth chip, everything more than just IC is we call MTM. And you can see the opportunity in the global semiconductor industry. You can see more, it got market share around 33% of the global. It's not it may smaller than the IC industry, but it's not that's smaller. And for this one, from our information from 2021 and 2023, we got a new investment on this MTM sector. I think we got the Sony come to Thailand, and Infineon for the packaging and testing come to Thailand as well. And yeah, this one is not yet come to Thailand, but we hope, yeah, in the future, if we got everything right for them, they will come. But for now, we got these two companies come already, and this is a good news for us. And this one is a study that we do in TMEC. We try to optimize the investment for this kind of MTM fab if we got to make ones. And it comes down to that we can make one new foundry. The price start from 10 billion or to 100 billion baht. but it's just 5% of a new fab of IC fabrication. So the chance is still got here, but of course it's quite a lot of money, but it's not that kind of money for the IC fab. So, and as we study, the MTM fab can generate the job around 300 to 1,500 staff per fab. So if we have this more in Thailand, so we can generate the job as well. And I will introduce you to our lab, the Thai microelectronics. The 15 years that we work on to keep the knowledge in our country. So what we achieve, because we got quite a big lithography technology, right? 3.5 micron. So we follow the more and more device, like a MEM sensor. We can do the pressure sensor, microphone, gyroscope. All this can be done in TMEC. We know how to do that and can actually finish the device. And another device that we have finished already, we got looking into the kind of power device, like a silicon power diode, and some kind of particle counter that we done the project with Mahidol to send the sensor into the Thai satellite or something like that. It's called particle detector for gamma ray. That project is done by TMEC as well. And we can modify the MOSFET structure to be ion selective FET and can be adapt to make a chemical and biosensor on this platform. And of course, I show you that recently Thai government have a campaign for us, or to teach or upskill our students. So on behalf of TMEC, we have exhibit the training course as well. So this one is quite new. We try to make the training to show how to make a pressure sensor in TMEC. You can know how to start with the design, layout design, simulation, and the training will continue around from simulation and finish to the PCBA level. So you can use the sensor that finished and prototyping it to and ready for the field test. We can show you how to do that on this training. And the process in the clean room, we will try to make a live streaming every day. We will have a schedule to do the process, and you can online looking into our process every day. This is our plan to do the training, and everyone can get to do the training by online as well. You don't need to come to Chai Hung Sao, but if you want to come to Chai Hung Sao, we also welcome as well. It will start maybe early of the next month. So I just give this QR code for you to scan if you want. It's a form of application that you want to apply to our training course. So that's it from us. So thank you.
Thank you very much, Dr. Putipon, for sharing your viewpoint and also an interesting project that TMEC are working on. As Ministry of Higher Education, Science, Research and Innovation, or Mahesi in short, set up the policy to ignite Thailand again through the capacity building of semiconductor, AI, and EV. How would TMEC see and how would TMEC would accommodate this national policy to ignite Thailand? And are you open for collaboration with partner from other institutions?
Yeah, we quite very happy if everyone want to use us as a lab or a central lab for their working on training staff or student. Yeah, because we also in our work as well, so we can have a service to all of university that have the course on the semiconductor device. And when you come to TMEC, like I said before, and that we plan to do, we can show you how to make the silicon chip. We actually can make the CMOS circuit as well, like IC design as well, but quite a big scale. I mean that for the functional device on CMOS, that we can probably make it right is around 1.8 micron node. So it's quite a big one, but it's functional. And the process of the stacking up, the etching, patterning is the same on this advanced technology today. So the student can learn the same step of technology. And I hope that when the student come to learn from us, they can have the more understand of the what it done and how it's produced the chip, and it will help to the IC design student as well to see the clearer what they design and how to produce the chip, so we can provide the service on that.
Thank you very much. So after we hear from the three panelists, at this point, any quick question from the floor before we continue? Please feel free to ask questions. Yes, please. Oh, okay. Well, later at the end of the session, we will briefly introduce our new program on the semiconductor engineering. Thank you very much for your interest. Any question related to what the three panelists share with us? If not, maybe you can save your question for later. Next, as this the title of this special session, Human Resource Development. Okay, and as you share with us from the past until present of the semiconductor industry, R&D, the capability of the company from the past until now. Okay, but from now toward the future. Okay, if we are going to together grasp the opportunity that would present to Thailand and all the country in Southeast ASEAN. Okay, how you would connect? I mean, how we should partner together, like public, private, and also the university to contribute to the human resource development. Okay, in order to be able to grasp the opportunity just right in time. Okay, and related question is, I see many countries develop so-called national semiconductor strategy, right? National semiconductor strategy, and if you are, and perhaps you are one of the team who will write the Thailand national semiconductor industry, what would you suggest that how would we write up the Thailand national semiconductor strategy from your viewpoint and from your experience? Okay, and how would the program like a Chulalongkorn University, ลาดกระบัง เกษตรศาสตร์ มช. try to open up the semiconductor engineering program? Would that also fill the gap, also support the direction that you want to see in the Thailand national semiconductor industry? This round, let's start with Dr. Aniwat.
Okay, may I get back to my slides? Okay, thank you very much for the question. Before we go to the talent development plan of FT1 and PDT, let me share you a bit more about the process to be happen in our fab. is semiconductors processing steps that Dr. Puttapon has already mentioned. And I would say that the semiconductor processing is one of the most sophisticated processes in the world. Starting from loading of the raw material or raw wafers into the plant and until we can get the final pattern wafers out from the plant, it would take like 2 or 3 months. That shows how complicated the process are. Okay, for example, here it would relate to many processes, starting from the lithography, etching, developing, doping, deposition, and so many processes that involve multidisciplinary of subjects. So I can say that there wouldn't be only an electrical engineers or mechanical engineers in the fab, but it would need a lot of variety of the disciplinary of students and talents in the plant. So it is I'm personally very happy when I heard from Ajahn Nabun that Jula has a plan to develop a special curriculum for semiconductor engineers, because it's a very good opportunity for those students to expose to many processes in the plant and would develop to very highly skilled talents in the future. But for the short term of FT1, because we would need the skilled laborers when we start the operation in the next 3 years. So we are going to send, actually we have sent some of them to foreign countries where our technological partner is having the operation to get the on-the-job training for the process. I can say that even that, those operators would need more than a year to learn how to operate all the processes in the plant. On average, they will stay in that country for more than 2 years, just in order to get back and work for us. Okay, so we have to take this long time because those operators didn't have enough ground or foundation for the semiconductor processes. But if Jula or other universities can create more talent, more skilled talents, it will shorten the process. And I can say that FT1 will build a very close relationship with Jula and other universities as well to get the students to do the internship programs at our plants every year for more than 6 months for each batch. So I think that will help each other from the academics point of view and also the industrial point of view. Okay, and okay, I will change a topic a bit, okay, to answer to Ajahn Nabun's question about the national strategy. For PDT or FT1, we know that only by ourselves, we don't have enough or sufficient power to drive the country. Because one of the most important disadvantages of Thailand so far is that we don't have a clear national strategy for semiconductor industry, and we don't have supportive policies for them. Okay, so PTT and FT1, we have discussed with a lot of private sector companies, such as Silicon Craft, Analog Devices, Infineon, Delta Electronics, and so many other companies. And we came to a mutual agreement that we need an entity, okay, that can represent the industry. Okay, so we have found the Thailand Semiconductor Industry Trade Association, or THSIA. But I would frankly is still in the process of registration. But we are going to have the opening ceremony on 4th of next month, 4th of June. Okay, so we are having the opening ceremony. So if you have time and interest, please join. So our mission is to strengthen Thailand's position in the world and also in this region of Southeast Asia by collaborating among many players because we already have a lot of players along the value chain, but we just didn't have an entity to gather all of them and become a single voice to deal with government, to deal with other countries. So this THSIA will do just that. So our strategic objectives comprise of 8 aspects, but on the four of them on the top are our priority. Okay, we are, as you said, we are working very closely with academics to build up talents for the long-term competitiveness of the country. And we have been working very closely also with the government to draw the national strategy for semiconductor industry. And thankfully, in last October, Thai government has decided to establish the National Board of Semiconductor headed by the Prime Minister of Thailand. And that Board of Semiconductor, they have assigned 2 subcommittees to do 2 tasks. One is to build talent. The other one is to build national strategy. Okay, I'm the member of the talent subcommittee. And THSIA, we have had an opportunity to talk with the consultant of the other subcommittee to build the national strategy 2 weeks ago. Okay, so we are working with them to generate a sound and effective strategy for Thailand to move forward into this industry. But that will take time, and I think we will have to wait until the latter half of this year before everything becomes clear. And the third objective is to build a strong network of semiconductor players in Thailand and build partnerships with SIA of other countries like Malaysia, Singapore, or America. And the last one, this is very strongly related to FT1's mission too, because FT1, we are wafer fabrication, we are foundry. So if you look at the business model, we are actually a contract manufacturer to fabricate chips for the chip designer like Silicon Craft. But due to the lack of chip designer in Thailand, even we have foundry like FT1 in Thailand, that wouldn't help much Thailand's economy. Okay, so we step back a bit and try to think of another business model of FT1. We think that because Thailand has a lot of downstream players, like the final assembler, the assembler of refrigerators, air conditioners, chargers, or inverters, something like that. But even we go to meet them and tell them that, oh, if you use our silicon carbide chips, you can improve the energy efficiency of your devices. They would buy that idea, but in reality, they don't know how to implement such high-tech chips into their products. So that's why we have tried to establish a new model that FT1 is co-developing a power board solution, a power management solution that consists of silicon carbide chips on it, But that board solution is ready for those downstream players to just plug and play the boards into their final products so that they can improve their competitiveness in the global context, they can improve their performance, they can reduce the energy loss in their products. Okay, so this is what we think that it will benefit Thailand the most because we will build the ecosystem or local supply chain along the way. Because we need design house to design the board. We need the PCBA to assemble the boards with silicon carbide inside. We need integrator and also the software developer in order to integrate all of this into the final products. And as Dr. Puttapon also said, back to the wafer fab, we have worked on this project for a few years already. And when FT1 tried to build up the wafer fab in Thailand, we have faced so many problems. The most important is the lack of talents, but that's not the only reason. That's not the only problem. We have also had a lot of other problems like we don't have the high quality suppliers for special gas, special chemicals, the waste treatments, and also the operators for to do the O&M, the operation and maintenance for our equipment, because all of the equipment has to be imported from many countries, and because Thailand has a very small market for wafer fab. So such makers won't think to establish the support service center in Thailand and so on. So I think we need to think about a plan in the long run, okay, to build up gently this kind of creation of the new ecosystem. And this would be my last slide. We should aim high for Thailand. Even we miss, okay, we will land among the stars. If we don't start today, we won't catch up in any near future. And thank you.
Dr. Yun, you mentioned that the operation in the fabrication plant require multidisciplinary. So your recommendation, if we are going to train our student, it should be like one person got the multidisciplinary, or we can work as a team. Some of them specialize in electrical engineering related, another of them chemical or mechanical. It's like, do we need to build multidisciplinary in one each of the students?
I would say we need both, because in some part of the process, we really need one person that knows many things. Okay, for example, if you are the engineer of the deposition process in the fab, you would need an expertise in both chemicals and also advanced materials. And you would need to have some understanding for the electrical properties of such devices or materials too. But I can say that mostly several people can work as a team. If they can work along well, that will answer the problem too.
I see. Thank you very much. Kun Kan, if we don't want to wait until they write the national strategy, so to speak, what would be the national strategy on semiconductor for Thailand in your vision or in your dream? And as you are from the only the one local company in Thailand that can do the IC design, if to your wish, what would be the national strategy?
Okay, thanks for the question. But actually, I have my opinion on this too. But as a disclaimer, actually the Syrian craft strategy should be merged with the THSIA because we're working together. So many things will be aligned. And my thought is also very in alignment with, okay, may I stand a little bit? Yeah, Dr. Aniwar is so tall, even he's sitting still. Okay, my thought is, the font is a bit too big. Okay, I hope you can read it. I think there is chance for Thailand to be the ASEAN leader. Thinking about our strong point, I divided my thought, my strategy into 3 phases. So that short term, that's long term, but the long term that is very important that you have to start something now. And last one is the medium term. So if it can wait until that long, like 5 or 10 years later, that's not important at all. So this is how my strategy is arranged. So two first thing that we have to focus is what we already have. The strong point in the back end, we have to leverage that into the very competitive back end like chip packaging and assembly and test house and also the final product. And to do that, we need very capable workers or staff. So we have to do upskill and reskill a lot just to make them, everyone still, maybe just still to have work to do, not to be laid off because of the new technology. So we have these two will put what we already have a strong point to remain in the competition. Then we move to the longer term because this thing you invest and you have to wait. You can just decide with the result in the first or second year, which means because we have to build people and people really need time to grow. So just from electrical engineering turn into a good designer, it's already like 2 or 3 years to make them stay in the whole process, starting from designing and in the software in the computer, and you see the diagram, you see the simulation result, but that's not all the chip design is all about. Actually, you have to tape out, turn it into the real chip, and get the real sample back and do the test with equipment. Everything will show up at that. All the non-ideality you learn in the textbook will come out and hit you, and you have to show that in every way, every knowledge, every tool you have to fix them. And that would take like a few years. And then for all the process fixing and redesigning and making a new sample, that make you the real designer. So that the long term that we have to build talent. And it also applied to like the fab, the OSAT, the packaging also. And also we have to promote the IC design as a national agenda too, because one part, as I mentioned earlier, is that we have the good analog guys, even though it's still a lot is in electronics field, not in IC design yet. But as we have a lot of soft power and crafting skill, and Thai people nature is also good at art, and analog design is a lot related to art of fixing non-ideality, noises which did not happen in digital at all. So in software everything is systematic, but in hardware and analog they are both systematic error and stochastic error, let's say. And we are somehow good at that, and we should leverage from this cultural strong point. And last one is to bring up some local tech companies and maybe startup, maybe SMEs at all possible. But we need them to grow the ecosystem altogether. And just maybe touch that very quick. So we have the Semiconductor Sandbox program running right now, and to my experience, this program is very good because Silicon Club also doing this like almost 5 or 6 years in recruiting the new talent, because we don't have we have less and less hardware engineer. Like a few years back, we have to build our own, so we go into the lab in the universities to inspire everybody through the special talk, orientation, doing the IC design contest, and bring them the very kids who interest in our work in IC design, taught them through the internship with the project-based problem. And then if they choose to continue this path, we do the senior project together, and sometimes they can go on into the higher education. Yeah. And second class also work with many government sectors like BOI, policy making maker agency. They come to see how IC design works and what is the semiconductor industry looks like. So we help them to understand more, and we work with many people from government. And finally, so this is my last slide. So my thought is we already have an entity, but one question is an individual can contribute to the semiconductor, or in the bigger picture someone can contribute to the future of the country. So this slide is my answer. So I will go to the point a little bit later. What question we as an engineer usually got is, do Thailand has actual technology, or there is any technology that is built or developed by Thai people? But it's hard to think about because we are the user, not the maker, and that the reason is not maybe the tech is too hard, the money is too late, the government is not supporting, but actually it's about the people. It's how the people see the technology. They see them too hard, too far to reach. We are not in the math and science career path, so we don't have to know about it at all. So that's how most people think about. And we can see we work, from my experience, I'm working in the company, but I work with university. Now I work back with the high schooler, and now I have my own kids in in the nursery. So now I know what outside people see about the technology in Thailand. So they don't know anything at all. I would say the pipeline for engineer or people development is broken. So they come from 10 teenage, and now they starting dropping off, go to something else. So what they choose, the choice in their life at the entrance, TCAS, is to be doctor or to be engineer, and the other thing else. And they choose between which university had more famous, which faculty is more easier to enter, or which their grade, their score could fit into. So that's how they decide things, which is for us as an adult, and we see all the career. This is very crazy way to choose their life in 40 years ahead. But actually they don't know. They have a clue, or no one telling them. So that's why as an individual, I think I want to start sharing the story of myself working as an IC designer. So I start making a page, usually in Thai. So sorry for international audience, but this is for Thai people. So I use Thai language as a main message to carry out to the audience. And what I want to achieve from making this page is that I would like to tell everyone that not every person has to be an engineer to understand the importance of the semiconductor industry. But they have to get the picture that this is the industry that important for the Thai future. And everybody can act in some way that they could. Like parents, they can understand the semiconductor and know that why their students want to learn this and not obstruct them. The students or the high schoolers know that, this is one of the career choice that can make, if they go choosing this path, they can make something that can change the world, something like that. And even the general public still can understand the importance of it. So that I hope that by making this, I can achieve my vision that the next generation of the people will understand that Thailand can be a better place to live. Yeah, thank you.
Thank you very much, and I am one of the follower on your semi-mai by P Mai. Very
Thank you.
interesting stuff.
I have some little souvenir. If you stay until the end of this session, I will have a
Okay.
small token for everyone here.
All are invited. One quick question. On the contrary, I spot in your proposed medium term about the startup. The startup in semiconductor related technology for Thai people, is it possible? Is there a place for the startup in this industry for Thai people? Could you kindly give a tangible example of
Yeah, thanks a lot. This is a very good question. So it have to be only one segment in the semiconductor, which is the fabless. It has to be fabless because it's only the one that doesn't require the capital. You don't have to set up a factory, so you need just the licensing fee, which can be managed somehow. Yeah, and you need people with good idea and know how to design chip. And for example, in Israel, there are a lot of IC design company, and they usually, when they success with the prototype, they usually take over by US big guy like NVIDIA, like Qualcomm. They buy Israel company a lot. So that kind of startup I'm talking about.
I see. Thank you. Now we come to Dr. Putipon. If anything you would like to add on to help Thailand leapfrog to be the leader for this industry, especially in the area of upskilling or grooming the new talent.
So as part of I work for the government, so we need some private company like this too to lead the market. I think because in on behalf of I'm a government agency, we can compete with the private, right? So we have ability to help if the private section want for us to improve the staff skill or something like that. They come to use our facility to do that. We welcome that. And for the aim of the market, I think in my opinion, the semiconductor industry is quite the industry that can make a very large number of the device. So you need to look for the real potential customer that can buy you a large number of your unit that produce. So it's quite hard for us to think instead of the private company that because they have to find the potential customer and they have to make a deal first before to produce anything after that. So that's quite a hard thing to do, and I think we can have a hope on our private company that do the task for us, and we can help if anything that they want, something like that. Thank you.
Especially on the upskilling
yes.
talent.
Talent,
Thank you very much.
something like that.
And due to we are running out of time, maybe just a brief introduction about the program. Apologize for. Can you switch on to theฬาลงกรณ์ University slide? It's a four-year program, and we make it an international program under ISE and also the Department of Electrical Engineering. And people are asking us why Chulalongkorn offer this specific semiconductor engineering program. Actually, the key motivation is that we, Chulalongkorn, would like to support the initiative like Dr. Aniwat mentioned. If Thailand are going to set the very first factory in fabrication, we as a university would like to support this initiative as much as possible, especially in terms of capacity building. We would like to help the country to have the company like a silicon craft a few more IC design companies start up in the next 5 to 10 years. And also we would like to work together with our strategic partner to find the new opportunities. So our program would put an emphasis on three areas, that is IC design, fabrication, and also photonics. Okay, and along the design of the program, the first 2 years will focus heavily on foundation in mathematics, in chemistry, in science, in electrical engineering, electronic, and also foundation in semiconductor foundation like chemistry, like thermal fluid, something about thermal dissipation. So the first 2 years focus on foundation, and third year and fourth year we try to design our program toward what we call personalized learning by giving each of our students, okay, an opportunity to explore their strength, their interest, okay, and the journey during the third and fourth year, we design, we co-create with our strategic partner locally, like Silicon Craft, like PTT, FT1, like a TMEC, and we also work closely with the leading. This is a program. First year, second year, you can see. If you see from the course list, it's more on like a strong foundation, okay? But from third to fourth year, okay, we will arrange the teaching and learning, okay, in the way toward personalized learning, problem-based learning, project-based. For example, some of our students who are interested in fabrication, okay, the third and fourth year they are going to, they have a chance, opportunity to stay in Taiwan, okay, and wrap up the fourth year with the 1 full year internship with the real industry in Taiwan. Like as Dr. Yun mentioned that for the internship, it would require at least 6 months, and we talked to our strategic partner and they confirmed that internship cannot be done less than six months for the program that we work with Longhua University in Taiwan. Okay, our student will have the 1 full year internship during the last year. Okay, and for those students who are interested in IC design, in photonics, okay, we will do the same. But and it can be taken place in Thailand together with our strategic partner, or it can be taken place in the strategic partner like the university in Taiwan. Currently we are working with a few leading university in Taiwan, okay, and we are also exploring an opportunity to work in a similar fashion with our friend in Japan and also in South Korea, okay. Those are the three things. And yeah, and we will guide. This is in the middle is the key focus of our program. That would student could do the project, could practice their skill through device, circuit, and IC. Okay, and they will got the clear picture and connect from the foundation toward the application in telecommunication, in AI, in EV, or in renewable energy, something like that. So due to and the program is co-created with our strategic partner, for example, as shown. And since this is quite new to our younger generation, still target prospective and their parents. So we would like to ensure, especially their parents, that once students graduate from this semiconductor engineering program, they got plenty of opportunity to work in Thailand, or even we will encourage them to be the global talent where they can work anywhere in the world as they like. I think that's all. And we will currently the Department of Electrical Engineering create the new platform like where students could have the playground, so to speak, playground, where they can plug in their prototype, their project, and see if it works in the very close to the real world environment. We name it Gayward Square. So you are invited to visit Gayward Square. We will open this new platform at the end of this year. And for more information, you can follow our website. And I think we only have remaining time for one or two questions from the floor, and I apologize for that.
Okay, so there's always when talking about the talent, there are always two sides of people, like hard side and soft side. So both is required for like high tech industry. So at first hard skill, for sure they need to have good understanding of mathematics and physics base, and also in what they are going to do. Like if they are IC designer, they have to get a very good background in circuit and IC design, how analog or digital. And if they are going to do a process engineer in the fab, they have to get very good understanding on the material and chemical engineering. And on the soft side, that is more important. If they want to going into like expert or fellow, so they need to not only working with by themselves, but they have to collaborate well with others and working together in a team with the good project management. They manage themselves well and they can communicate with other people well. So they know what they are good at, and they also know how to work with other people who may be good at a different thing from them, but together they deliver the result. That's what we want
We'll
to see.
hear two more questions from the floor, and then I will ask the panelists to answer. Yeah, one more question from you, and that last question from that gentleman. Please.
Hi. Yeah. So far, we are talking about like the first line engineers in a fab or in a company. But what about technical management? Because do you have statistics of Thai students working or studying abroad, like in the United States? I come from Taiwan, and my understanding, I come from America and Taiwan, but my understanding is that in the 1960s and 70s, all the graduates from EE or physics, chemistry, they all went to the United States to get their degrees and then work there. But then they met glass ceilings in companies. And so in the 80s and 90s, I think Taiwan is just like right now, in Thailand, you are trying to develop this industry. And so many people who are promoted to mid-level management, they could not be promoted higher. And they met glass ceilings. So they saw this opportunity in Taiwan. So they went back to Taiwan and became technical managers. So managing, the engineers. So, for example, Morris Chang of TSMC. So he was a VP at Texas Instruments, but then he couldn't go up higher. So he went to Taiwan. Okay, that's the best example. Okay. So that's kind of one question about your Thai expatriates. Okay. The other question is, like a lot of the fabs, actually, you don't need, you need, of course, you need engineers to oversee the different instruments. But the actual operation is done by operators. And these operators, they just need high school degree, you just need high school degrees. And so I wonder whether you have any kind of program for this. Yeah, thank you.
Thank you very much. And that gentleman for the last question, and then if the panelists would address to the question.
Yes, thank you for interesting discussions. I have two questions.
Okay.
The first question is that because recently, maybe this year, at least 3 programs related to the semiconductor engineering is launched, not 3 or 4 programs. And if we launch this program and the student who will graduate in the future, I want to ask for the private sector that their vacancy positions, it meet to the number of the graduation students in the future or not. and because and the next questions is because the semiconductor industry is like if we can divide this is mainly divide this into like the chip designs and the fabrications. Fabrications is maybe divided into like two fabrication like wafer fabrications and device fabrications, and the last one is like assembly, the packaging or something like that. In the PTT new factories in the new PTT new factories, the factories also run the production on of the upstream and downstream, including the like a T main sector or not, main section or not. Yes.
Okay, I apologize for the time limited. Dr. Yun, would you like to address on the question from the two gentlemen?
Yeah, okay. For the operators, okay, so for Juฬาcurriculum, they are producing engineers, of course, and but the lack of the vocational education is also one of the most important focus of THSIA. We are now trying to build up a new program by partnering with some universities, especially one very interesting potential solution is to make use of the Kaizen program. It is a vocational curriculum of Japan that they are working with KMITL University in Thailand. So we want to merge that Kaizen program into the preparation of the vocational operators in the near future. Then
Yeah.
Oh,
I
okay.
think that's all we have. You are invited to discuss with our panelists after this session. With that, may I invite all participants to give a big round of applause for our three panelists.